Okay, now let's look at part B of question 6.9. It says, referring to your answer in part A, what must be the population mean be changed to if the probability of exceeding the value of x found in part A is reduced from 10% to 5%. So it's telling you what should be the new population mean. So we are changing the population mean, okay? And we are also changing, or we are looking for a new population mean, and we are changing the probability, okay? So what's happening here is that this mu is no longer valid anymore, so I need to cross over that. I don't need this. I'm looking for a new mu, so that's the value of interest. So mu is not given. I found x in part A. Is telling you to keep x as it was. It says referring to your answer in part A. Okay. So we keep x as 6.14. Sigma is not changed, so remain the same. Now, and something has changed is the probability. Probability is no longer 10%, it's 5%. So that area, this area, is now 5%. If that's 5%, therefore this area would be 45% this time. Okay? So again, let's write the equation as we had, z equal to x minus mu over sigma. X is known. X is 6.14. Mu not known. Sigma is known. 0.5. What was z? Z, now again I need to find z from the normal distribution table. I go to this table again. This time from mean to the value of interest is not 40%, it's 45%. So I'm looking at 0.45 in the body of the table to find the corresponding z. Let's find the closest to value to 0.45. Okay, let's look at these two values here. These and these, they are apart from 0.45 with the same distance. So basically 0.45 would be exactly in the middle of these two. So I'm looking at 1.645. So z would be 1.645. Now again I have three values. I'm looking for one missing value. Easy to solve this equation now. 1.645. I need to point something important here. Remember, x is on the positive side, so 6.14, and I get the z value which is 1.64 and it's positive. Remember, if I was dealing with some value here, if x was here, okay, no matter if it's positive or negative, z corresponding z to that should have been a negative value. Always remember that, that's an important point. Okay, so because in the normal distribution, in the standard normal distribution of the z value, mean is always 0, values here are positive, values here are negative. Okay, that's an important point. So z is positive, I put the positive value here, equal to x is 6.14 minus mu, I'm looking for mu, sigma is 0.5. Now I can solve this equation. 6.14 minus mu equal to 1.645 times 0.5. I'm basically bringing this mu here and this factor to the left side. 6.14 minus 1.645 times 0.5 equal to mu. So if I solve this, mu would be equal to 5.3175. Okay, question telling you what the new mu should be. So the probability of anything larger than x, which is 6.14, is only 5%. Now that mu is 5.3175. So quite straightforward. It may look complicated, but just be careful how you read the question and understand the question. The rest is just plugging the values into formula, and be careful of which value on which side. If you draw the graph as I did, that's gonna help you a lot to visualize where the values are located. Okay, see you next time with another video.